Hello and welcome to Maths with Jacob. This lesson will focus on special binomial products. Following on from the previous lesson, we have three special binomial products that will be used extensively in the future. The first one is a plus b all squared. So a plus b is a binomial, and then we square that. So that's how we expand it. And then following on from that, we saw earlier that that's how the expansion follows. When we remove the grouping symbols, we get that algebraic expression, and when we collect the like terms, that's the final answer. So the first special binomial expansion is a plus b all squared. Then we have a minus b all squared. So we follow through the same procedure. Squared means you multiply it by itself, then you break it down like that, you remove the grouping symbols, you collect the like terms. So this is our second special binomial expansion, and this is the third one. This is called a product of a sum and difference. So you have a plus something, a minus something, and the two terms are exactly the same, except here you have a plus sign and a minus sign. So we'll just go through the normal procedure, and you'll notice when you collect the like terms, we end up with a squared minus b squared. So in summary, when you have two terms and you add them together and you square those terms, that's what you get. When you have two terms and there's a subtraction or minus sign between them and you square them, that's what you get. And when you have the product, excuse me, of a sum and difference, that's what you get. Now, what does this actually mean? Well, there is a very simple procedure where you can actually write the answer down without doing any working. So for one, when you see something like this binomial here, when it's squared, the way you arrive at the answer is this. You square the first term, that gives you a squared, plus twice their product. A times b is ab, and then it's twice their product, so it's 2ab. And finally, plus, because it is a plus sign, square the second. So you square the second term. So basically, it's the first term squared plus twice their product plus the second term squared. When you have a minus b all squared, we have square the first minus twice their product plus square the second. So square the first minus twice their product plus square the second. And when you have the product of a sum and a difference, square the first minus the square of the second. It's just a squared minus b squared. So let's see how we apply these rules to just a few examples on the next slide, where we don't need to show any working. If we follow this rule here, these three rules, for each of the different cases, we can just write down the answer. Let's start with m plus 5 all squared. So for this one it says m plus 5 all squared. The rule says square the first, which is m squared, plus twice their product. 5 times m is 5m, twice 5m is 10m, plus the square of the second. So you can go from there to there, no working involved, just follow the rule. Similarly here, square the first, so 3y all squared is 9y squared, twice their product, that's 12yk, twice their product is 24yk. And finally, square the second, which is 16k squared. Now, when you have two terms and there's a minus sign, square the first minus twice their product plus the square of the second. The only difference is between when you have a plus and a minus, that is a minus there. This one here again, square the first, which gives you 64h squared, minus twice their product. Now the product is 24hm, So twice their product will be 48HM with the minus sign, and then you square the second. So square 3m to give you 9m squared. The product of a sum and difference, the first squared minus the second squared. That's an easy one. The first squared minus the second squared. That's it. Similar, the product of a sum and a difference. Doesn't matter if it's a minus or a plus. It doesn't matter about the order. You can have 9k plus 7s and 9k minus 7s. The order doesn't matter. This is still the product of a sum and difference. Square the first gives you 81k squared. Square the second gives you 49s squared. Put a minus sign in between. And finally, exactly the same thing, the product of a sum and difference. So that's exactly the same, and that's the same as that, except you have a plus and a minus. Square the first gives you a squared b squared c squared, minus the square of the second gives you d squared e squared f squared. So this video has introduced some very special expansions, some binomial expansions, and we've shown how we can arrive at the answer just by following 3 basic rules. And the more you practice with examples like this, the much better you'll get, and you'll be able to write the answer without any trouble. It just requires some practice and just a little bit of confidence.